What's going on, guys? This is going to be our last video in our IPv6 lessons. My name is Johnny Bandon, and I'm going to be your instructor. And in this video, we're going to go over something called the modified EUI 64 format. This is a feature of IPv6 that allows a host device or an interface to assign itself a unique interface ID. So let's imagine now that we have host A, and host A is assigned to this prefix, or actually 64. Let me clean that up a little bit. So again, we have this prefix that our host is going to be assigned to. So this is a global unicast prefix. Now we know that there's only 64 bits in this first half of the IPv6 address. So now we need another 64 bits to make up the host portion, or what we call the unique interface ID. So modified EUI64 format allows this computer or this host to generate its own unique interface ID. So how does it do this? Well, the EUI64 format has two parts to it. The first part is you're going to take the MAC address of your interface, which is also hexadecimal, and it's 48 bits. So let's say host A has this MAC address, AABB:1122:CCDD. So step one of the EUI64 format is you're going to convert this MAC address into your unique interface ID. Now you may be saying, whoa, hold up, man. That's only 48 bits. We're missing about 16 bits of address that we need to make up a full IPv6 address. Well, I got you. In the EUI64 format, what you're going to do is insert the hexadecimal digits FFFE in between what we call the vendor OUI and the unique part of the MAC address. This is the vendor OUI. This is going to identify a company, right, or a brand. So all Dell laptops, Inspiron 1900 series will have the same first 6 hexadecimal digits in their MAC. And then this last 6 is going to be unique. So part 1, insert FFFE in between the vendor OUI and the unique part of the MAC. This is going to equal 16 bits, the FFFE, and we're going to insert it right in there. So now our new hexadecimal digit, which we're going to add on, right, to this global prefix to get a complete IPv6 address, is going to be AABB:11FF:FE22:CCDD. All right. Are we done? Well, that does complete an IPv6 address, but we have one more step, okay, guys? And that's going to be part 2. Remember, this is 64 bits total. So take 64 bits to create this hexadecimal digits right here, right? What we're going to do to these 64 bits in part 2 of the EUI64 format is we're going to invert the 7th bit. Now, what does this mean? We have to figure out the 7th bit, flip it, right? So change a 1 to a 0 or a 0 to a 1, and then recalculate this second hexadecimal digit. So how do we do that? Well, first, we got to take this hexadecimal digit and convert it to binary. So take it, and we're going to convert to binary. So we have our binary positional chart for hexadecimal. A equals 10, right? Because it's a base 16 format for IPv6. So hexadecimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. A equals 10, write the number after 9, 11, so on, and so on. So we're going to see through our binary conversion, right, using this chart here for IPv6. Because each digit is 4 bits total. So is 10 equal to or greater than 8? Yes, it is. Is 2 equal than or greater to 4? No, it's not. Is 2 equal than or greater to 2? Yes, it is. All right. Now, this first hexadecimal digit has 4 bits, and this has 4 bits. So this is going to be the 5th bit, 6th bit, and 7th bit. So we're going to change this 1 to a 0. So now our new 4-bit digit here is 1000. So if we convert 100 back into hexadecimal, we get the number 8. So now our complete IPv6 address is our global prefix, then A8, you see that change there, right? Because we inverted the 7th bit, converting this hexadecimal digit A to hexadecimal digit 8. BB, colon 11FF, colon FE, colon CCDD. And now this is our brand new IPv6 address. All right. And that is going to be the last thing we go over for the IPv6 exam objectives in the CCNA. I hope that this videos have helped you guys study, and please stay tuned for our next videos.